Hello friends, welcome to Veranda CA. Let us continue with the rest of the part of chapter 3. So we're going to begin with data mining. What is data mining? Digging out data to find out unknown trends in the data. If I want to find out which region my sales are going to be more, if I want to find out in which zone my employees are performing the best, so I can take data, use some data mining techniques and run queries to find out unknown trends from data. So data mining, it is analyzing data to find out the previously unknown trends to make decisions. Example of data mining tools are Oracle data mining, R language, MS Excel access, right? So these are the basic data mining tools that are available for us to analyze the data. Next we have steps in data mining. It's an important question. Steps in data mining. The code word would be data mining is super clear to me, PD. Is super clear to me, PD. Is I. I for integration. I for integration. S. S for selection. First you integrate all the data from various sources. It could be from your database management software, it could be from text files, it could be from social media, wherever. So you integrate all the data. Then after you've integrated so much of data, not everything will be required for making the analysis that you need. So next step would be to make a selection of data on which you want to apply the analysis techniques. After you select the data, data cleaning. Data cleaning. You clean the data using techniques. Data cleaning. T. Okay. Data transformation. Data transformation. You transform the data into the format that is required, and then data mining. The actual data mining, the process of running techniques to find out the pattern. Okay, data mining, patterns, pattern, and then D is for decision making. D is for decision making. Clear? So steps in data mining. Data mining is super clear to me, PD. Super clear to me, PD. So I stands for integration, S for selection, C for cleaning, T for transformation, M for mining, pattern and decisions. Data integration, selection, cleaning, transformation, mining, pattern, evaluation and knowledge, presentation and making the final decision. Clear? Now here is just a quick glance to the differences between what is a database, data warehouse and data mining. Now this database, data warehouse, the name sounds similar, it means storing of data. So the database stores information on a real-time basis, but data warehouse stores historical and real-time information, Data mining is not for storing the data, but for running analysis on the data, analyzing the data to find out trends. Now the function of a database is to record the data, Data warehouse is to record and analyze the data. Data mining, like how any coal mining is to extract coal. Similarly, data mining is to extract the data. Now the example of various tools, MySQL, MS Access would be the database. Data warehouse could be Amazon Redshift, Google BigQuery. Data mining could be R language, Oracle data mining. These are a few examples. This is just a quick glance onto the differences between database, data warehouse and data mining. Network and communication systems. Network and communication systems. We all know network. It is when a group of systems get connected to another group of systems. Okay. Physical devices and software. A network links two or more computers to share the data or resources. So even a printer would be a network tool because many computers can be linked to a single printer and the printer can be operated. So in office we have 50 computers, but do we have 50 printers or one printer? Just one printer, because so many computers can be linked to the printer and the printer can be given access to take the print commands from multiple desks. So this is the example of a network. physical devices to link two or more computers, What are the various types of network? 2-mark question. Types of network: connection oriented network and connection-less network. Connection-oriented network and connection-less network. So, if you try to dial a phone to someone, yeah, on the landline, say, so first a connection is established. So, the ringtone, it first beeps like this, tuh, 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 and then the ringtone starts, yeah, the caller tune or the tring, 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 yeah. So, when the connection is first established between the sender and receiver, and then the person picks up the phone and data is exchanged. Data is exchanged after that. So, in that case, it is known as a connection-oriented network. First, I establish a connection between the sender and receiver. Connection-less network: when you want to send an email to someone, you just send it and the person receives it at a different time. So, no prior connection is made before the data is exchanged. Before the data is exchanged, you don't need to make a connection, SMS or email, right? Clear, very good. Types of network: connection-oriented network and connection-less network. Now, issues addressed by a network. What are the issues addressed by a network? They have described 4 main issues addressed by a network. We have routing, bandwidth, contention and resilience. Routing, bandwidth, contention and resilience. Let us see each one of these. Routing. What is the meaning of routing? The route through which the data travels. For example, we all know that data travels through data packets. Now, these data packets, I say I want to access some information from Instagram, okay. So, Instagram servers are located in the United States. So, once that I send a request that, okay, I want to view a certain page, what it does is the data will travel from US server to another server in between, and then it comes to the Indian server, and then it comes to my mobile. So, data is traveling in packets, okay. Now, I have to design the best route for this packet so that no unauthorized access can be done in that route, So, routing is data transfer from source to the destination in data packets. Data is transferred from the source to the destination, from US to India in data packets using IP address, Now, this route needs to be very well established. Now, look at the question, issues addressed by a network. Now, a network helps me in coming up with the best route. Clear? Bandwidth. Bandwidth is the amount of data and the speed of data transfer. Amount of data that can be transferred across the network. Lesser the bandwidth, lesser the data gets loaded, and slower is the website. So, amount and speed of data transfer. So, a network helps me in increasing my bandwidth size, okay, as per the need. Next is contention. When 2 or more system resources are being used for this by the same person, then how should the system react? Okay, so contention is a sort of a conflict management. For example, if the printer gets a print command from 3 terminals, from 3 laptops, the printer is getting a print command. How should the printer decide that which command should I execute first, or what should I be doing, right? So, in that case, it is known as contention, where the printer can be designed to execute that. Okay, if the manager is giving the print command, along with that an employee is also giving the print command, please execute the manager's print command first. Yeah, please execute the so you can give certain guidelines to the printer. Conflict for some common resources in the network. Conflict due to some common resources in a network, 2 systems trying to communicate at the same time. In that case, a network will help me establish or resolve the contention. Next is resilience. Ability of a network to recover from any type of failure. Resilience, ability of a network to recover from any type of a failure. Example, connection failure. Clear? So the 4 issues addressed by a network. Come on, let's revise it quickly. 4 issues addressed by a network. Four issues addressed by a network. Routing, bandwidth, contention, and resilience. Clear? Benefits of a network. What are the various benefits that the network provides? Dr. Crew. Our code word for this is going to be Dr. Crew. Dr. Crew. Benefits of a network. D. Distributed nature of information. Distributed nature of information. Can a network help me in sharing of files? Yeah, sharing of files. So because of a network, I do not have to create duplicate files on all the terminals. Using a network, I can share these files across terminals. So distributed nature of information. R for resource sharing. R for resource sharing. 50 computers in a office, but 1 printer. So the printer is being shared between 50 computers. Resource sharing. D are Dr. Crew. C. Computational power. A network helps in increasing the computational power. It helps in load balancing between systems so that the systems are able to perform very well. So it increases the computational power of any system. Yeah. Resource sharing, computational power. Then we have user communication. Reliability and resiliency. R for reliability and resiliency. Reliability and resiliency means even if there was only one system that we were working on and individual people working on individual system, then if my system gets spoiled, then there's nothing I can do about it. The data that was there in my system will go for a toss. So in the case of a network, what happens is there are other nodes that are connected to the network, so my data is still safe. For example, take ATMs. Yeah, we have so many ATMs in a city. So in that city, in case one ATM stops working, there's not going to be an issue because the other ATMs are still up and running. It is because of the network. Yeah, so reliability and resiliency, the ability to recover from a failure is very fast due to a network. And user communication. Users can send emails and do a chat through the network, through using a network. Okay, so 5 benefits of a network. Dr. Crew. Everyone's clear? Dr. Crew. Distributed nature of information. D. R. R stands for resource sharing. C. C for computational power. R for reliability and resiliency. Reliability and resiliency. U for user communication. User communication. Clear? This is an important question as well. So now we have information system auditing. Very important, guys. So we finished data mining, we finished the types of network and the benefits of a network. We're moving on to the next important concept or the next part of this chapter relating to systems audit. Systems audit. Now, why do we need to conduct an information systems audit in any organization? What are the objectives? So this answer is going to be same as control objectives. Control objectives. What are the objectives of control? If you can remember, safeguarding of assets, safeguarding of assets, data integrity, system effectiveness and system efficiency. Effectiveness and efficiency. Now, what is the meaning of safeguarding of assets? When I say safeguarding of assets, my information system components comprises of my mainframe, my servers, my computers, right? So now in that I need to make sure, or the auditor needs to make sure that all the assets are with adequate physical and logical access controls. Physical access controls also needs to be in place and logical access controls also needs to be in place, because otherwise an outside hacker or cracker can come and invade the data. So safeguarding of assets, safeguarding of assets. Next point is data integrity. I need to ensure that my data is complete at all times, relevant at all times, reliable at all times. Yeah, complete, relevant, reliable, accurate at all times. So data integrity is very important. The auditor needs to make sure that the systems are working in such a way that they are generating data that is, people can, or the stakeholders can rely on that data. System effectiveness. What is the meaning of effectiveness? Effectiveness means the work is being done as planned and the system is not throwing up any errors or not, not performing. Next, guys, we have system efficiency. When I say efficiency, it means that using the least amount of time, resources and efforts, I am getting the work done. Using the least amount of time, efforts and resources, I am able to get my work done. Alright, so it is due to these 4 things that I need to ensure that I get my information systems audited. What do you mean efficiency in this case, in information systems case? For example, there could be certain extra computers in the office. The server room could be unutilized. The space in the server could be unutilized. So the management needs to know about all this so that they can take corrective actions. Clear with audit objectives of IS audit? Objectives of IS audit? Very good. Now moving on to the next thing, the need for IS audit. Again, so wherever the question says auditing, it is important because this is your chartered accountancy course where auditing is one of the core subjects. So any topic that has auditing in the question becomes extra important. So the need for IS audit. First one that we studied was objectives of IS audit. Now what we are going to study is the need for IS audit. Need. So in need, we have 5 points on cost, 1 on privacy and 1 on evolution. 5 points on cost, 1 on privacy and 1 on evolution. Okay, now the need, when I say cost, okay, cost of incorrect decisions. If I'm based on my reports, based on my computer reports, I take some decisions. Now, if the reports are wrong, my decision is going to be wrong. If my decision is wrong, I have implemented the wrong decision, so it's going to cost me a huge sum of money. So, cost of incorrect decisions, cost of wrong or incorrect decisions. Value of system, hardware and people. So, hardware, people, software, all of that comes at a value. So, value of all that, I need to ensure that my systems are working right, so that I do not lose out or I do not incur any loss due to my system, hardware or people. Clear? Cost of computer abuse. Cost of computer abuse. The employees can come together, collude with each other and abuse the computer, as in install some, say, ransomware and say that all the files are blocked, only if you give us a certain amount of money we will release the files. Yeah, so computer abuse, cost of computer abuse if your systems are not working well. Okay, so organizational cost of data loss. Okay, so under cost also one more thing is data loss. If data is lost, everything is lost. In an organization, how important the data is. Organizations survive, thrive and live on data. Now, right now, if this data is lost, then it is going to be a humongous exercise to retrieve it back. It could even be irreparable damage. So, organization cost of data loss. Cost of incorrect decision making. Cost of incorrect decision making. Cost of computer abuse. Value of hardware, software and people. High cost of computer error. One more point is computer error. High cost of computer error. In case the computer is making some mistakes in reporting. So, in that case, it's going to cost the company some amount of money. High cost of computer error. Maintenance of privacy. Nowadays, many companies are able to, through mobiles or through very low cost analytics where data collection is very easy. Yeah, even when you go to buy a pair of jeans, you have to give your name, your phone number, your date of birth. Yeah, so at certain small points you have some data there, and we're all just data points in this world. Now our data is there with so many companies. Now if this data is lost, if this data is given to some third party, and it could lead to some major Loss of privacy, major loss of privacy. Yeah, it could lead to events that we do not, that are unfavorable to us. Clear? Maintenance of privacy and controlled evolution of computer use. With the everyday invention of new technologies, with the onset of new technologies coming in, everyday computers are programmed in such a way that they can run on very different technologies that is evolving. Now, there was a Bitcoin exchange, yeah, Bitcoin exchange that was started, okay, in Canada. There was a Bitcoin exchange that was started in Canada. Now, here what happened is, when people invest money into Bitcoin, they could see it on their portfolio that, you know, so much of money is invested in Bitcoin, and day by day when it grows or it falls, they can see the real value of it, like how we can see in our stock portfolio as well. So, in the Bitcoin portfolio also they could see their money. But the computer was programmed in such a way that this money was not even there in people's account. It would go to some other exchanges all over the world. This money was not there in actually people's account. So, because Bitcoin is digital currency, they could not see it, you know, where it is, and they believed that it would be in their account. Like how we can't see shares, but if we see our portfolio, we know that, okay, these are the shares that I hold. Okay, so similarly with Bitcoin, when they saw the portfolio, they knew that these are the Bitcoins that we hold. When I say Bitcoin, I mean cryptocurrency. It could mean any coin, right? So now, but what happens is the computer is designed in such a fashion that this digital currency is just showing on the customer's account, but in reality, it is actually transferred to other exchanges around the world, around the globe. So the computer is programmed in that way. Had the systems been audited, this would have come in light definitely, but it was not done. So, controlled evolution of computer use, controlled evolution of computer use, not putting the computer to wrong use. Clear? So, 5 points on cost. Cost of data loss, cost of wrong decisions, cost of computer abuse, value of hardware, software and people, high cost of computer error, high cost of computer error. So, we finished 5 points on cost. Then there is 1 point on privacy, maintaining privacy, and finally there is cost or controlled evolution of computer, controlled evolution of computer use. Are we clear, guys? Are we clear? Yes? Okay. And this is an important question, need for information system auditing. Moving on to the next question, very important. Tools for information systems auditing. Tools for information systems auditing. Now we have 5 tools for auditing information systems. 5 tools for auditing information systems. Interesting bit. One is snapshots. As the name suggests, snapshots are tools that can take pictures through the data processing. It takes pictures of the transactional flow. As the transaction is flowing, in between, if it finds that, okay, something is wrong here, it takes the picture. Built into the system where material processing takes place, images of flow of transactions. It checks the authenticity, accuracy and completeness. This abbreviation AAC, I am going to use it throughout the audit tools. So, please note AAC, authenticity, accuracy and completeness of transactions. Now, what I need to do, or what the auditor needs to do along with the management, is that locate the snapshot points in system based on materiality. So, it is built into the system not at every step of transaction processing. It is built where material processing takes place. For example, any purchase order which is above 50,000, place the snapshot tool. Any salary disbursement which is above 3 lakh rupees, place the snapshot tool. So, built in the system where material processing takes place. So, what is important for the auditor and the management is to locate where this snapshot points needs to be placed and how to report this information. In what format or in what design should I report this information to the auditor? Clear? Image of flow of transaction where material processing, material means material to the organization. Material to one organization could be different from what is material to another organization. Clear? So, first is snapshot, clicking a picture. The next one is integrated test facility, ITF, integrated test facility. Creation of a dummy entity. When I say integrated test facility, it means that I am testing the processing system, I am testing the ERP, I am testing the application software. How am I testing it? Am I putting in dummy data within the same company? No, I am creating a parallel company or a dummy entity. In that dummy entity, I am inserting the data, dummy data. Creation of dummy entity, processing of test data. Now, this test data is just like my real data, because I need to compare the result of my company A with my dummy company B. Company A with my dummy company B. Auditing the results to check the AAC of transactions. Authenticity, accuracy and completeness of transactions. Auditing the results. Auditor to decide method to enter test data. So, auditor needs to do some sampling, or if he wants to decide what data he wants to put as test data, he needs to decide that. And the results he needs to compare with company A. Company B's dummy results he needs to compare with company A if they are on the same lines. Next is my SCAF tool, SCARF, Systems Control Audit Review File. Systems Control Audit Review File. What is Systems Control Audit Review File? It is an embedded software module within a host application. So, what I do is, it's very similar to my snapshot, just that this one is a little smarter, in the sense it has some data collection abilities, some data analysis abilities, alright. So, in many ways it is similar to the snapshot technique, where it takes a picture of exceptional entries, but it is a little smarter. Embedded software module within a host application. So, if my host application, for example, say is Tally ERP, okay. Within this Tally, I put one software module called SCAF. It is an embedded audit software module. This SCAF will continuously monitor the data. Continuously it will keep an eye and monitor the data. Information collected. Now, whatever information SCAF collects, if it finds something different or something worth reporting, what it does is it collects that information and puts it on to something known as SCAF master file, written onto a special audit file known as the SCAF master file. SCAF master file. You all know the meaning of SCAF, or the full form of SCAF. System Control Audit Review File. System Control Audit Review File. Now, this is written onto SCAF master file. Auditors examine to check if any aspect of application software needs a follow-up. So, this auditor examines if any part of Tally needs a follow-up. How will he decide that? Based on the report which is there in the SCAF master file. Like snapshot technique, but has more data collection and analysis abilities. It has much more data collection and analysis abilities. Clear? The fourth one we are doing, so far we have done snapshot, ITF, integrated test facility, where you create a dummy entity and then you have your SCAF master file, Systems Control Audit Review File, SCAF. And the fourth one we are doing is CIS, Continuous and Intermittent Simulation. Continuous and intermittent simulation. Now, what CIS does is, see, there is an application software, which means there is my ERP. Okay, I enter data in my ERP and I would like my data to be stored in a database. I would like this to be stored in a database. Now, when I am storing information in a database, it is possible that I write some program to, the transaction will look different, but when it goes to the database, it is different. For example, the closing stock as per my book will be different, but when I want to copy it to the database, I am editing the closing stock figure. So, if anyone audits the books, it is going to look all fine, but if they are going to come and see my database, what is stored there is going to be a different closing stock amount. Say for example, I have reduced the closing stock amount in order to reduce my profit, so that my taxes become less. So, my report, my database is going to have an other figure, and I am going to pay taxes based on the reports that I extract from my database, Clear? from ERP data flows to DBMS. DBMS passes this data to CIS. Now from the ERP it flows to my database or database management system. Alright, now so there is ERP here, ERP, okay. Then it processes the transactions, and then there is my DBMS, database management system, okay. Now this DBMS, it stores data here, it keeps storing data here. Now my DBMS, for every data that is stored, it asks a question to the CIS. Hello CIS, what do you think about this data? Is it good to go? Okay, now the CIS has to decide. So CIS has some smart techniques, some smart understanding so that it can understand the data. Now CIS examines every data if further examination is required. It examines if further examination is required. If yes, CIS simulates the application system processing. If yes, then CIS tries to process this, for example, closing stock. Okay, it tries to process this as done by the ERP software, as done by the, it simulates itself. You know the meaning of simulation, right? When I am learning to drive an airplane, I will go and simulate it. Means I will drive it on the land, but the entire environment will be made in such a way that I am flying the airplane in air. So ERP simulation. So a simulation is done as though it is the ERP software itself. Then it will understand that the result is coming as 3 crores, but what is in DBMS is only 2 crores, because someone at this point has modified the data. Someone at this point has modified the data. So CIS will understand that okay, the ERP is showing 3 crores, but my database management system is only having 2 crores. So then in that case, every update to the database will be checked by CIS. Any differences or discrepancies, yeah, or exceptions between the CIS and ERP processing will be written on an exception log file, This exception log file will be studied by the auditor to understand what has happened. Yeah, he will get a better picture to understand what is happening in the company. Are we clear about CIS? So what you need to remember is CIS is to trap exceptions. This is the important word. Even in MCQ, they will give some audit technique. In case law based MCQ, they will give some audit technique and they will say which audit technique is used. So in that case, if the word is trap exceptions, it means it is CIS. Trap exceptions, it is CIS. If the word used is continuous monitoring of transactions, it is the SCAF file, SCAF technique. If the word used is dummy entity, it is ITF. And if the word uses images, then it is snapshot. Clear? So images, snapshot, dummy entity, ITF. Okay. Then we have continuous monitoring, SCAF, trap exceptions, CIS. Okay. And finally, we have audit hooks. Audit hook. How you see the word hook? What it does is, it goes and picks up exceptional transactions, flags suspicious transactions. Audit routines. So if this is the word that is used, it is audit hook. Audit routines that flag suspicious transactions. So what happened in an insurance company? What happened in an insurance company is that people in their database, they changed the name and address of the policy holder. They changed the name, address, bank account number of the policy holder, and the withdrawal was done. The withdrawal, say for example, they put it in someone else's account. They would have put it in their relatives or their family members' accounts, the money which was, and then when the policy holder's family comes and claims for the money, they say that the money has already been withdrawn. So the management was taken aback that how did this happen? So in case name and address is being changed, yeah, and the policy holder or anyone is making a claim against that, okay, then this audit hook will flag that transaction with flag or mark. Flag means mark. Flag the transaction, saying, notifying to the auditor that you need to be extra careful with this transaction. Auditors can be informed of questionable transactions as soon as they occur. This happens on a real-time basis with the help of notifications. It happens on real-time basis. Clear? Yes. Wonderful. So, there are 5 auditing tools that we have studied. Okay. Number 1 was snapshot images of transactional flow at material processing. Number 2 was ITF, creation of dummy entity and using test data. Number 3 was SCAF, continuous monitoring and like snapshot but with extra collection capabilities, extra data collection capabilities, and there was something known as SCAF master file. SCAF master file. Number 4 was continuous and intermittent simulation. Continuous and intermittent simulation. The word here used here is trap exceptions. Trap exceptions, and this is for data not when it is getting processed through the ERP, not in the application system, but it is the after effect. Okay, after data is sent to the database management system. So, over there database management system asks CIS that okay, this is the transaction, is this good to go? CIS says yes, yes, yes. If no, then CIS copies it onto a log file, exception log file, and then auditor has to decide. And the 5th one was audit hook. Audit routine to flag suspicious transactions. Audit routine to flag suspicious transactions. Clear, guys, with the 5 audit objectives, 5 audit tools. Yeah, so first we studied was the objectives of audit, which are 4. Data safeguarding, asset data integrity, safeguarding of assets, system effectiveness, system efficiency. Then we studied need for information systems auditing. In the need, we had 5 points relating to cost and then 1 point relating to it was evolution, control evolution, and 1 point relating to privacy. Yeah, if you can remember. Next we studied audit tools. Audit tools were 5 types that we just revised. Finally, we have audit trail objectives. Audit trail objectives. So, it is for detecting unauthorized access. Detecting unauthorized access into any system. So, through the log files, audit trail. What is the meaning of trail first of all? Audit trail means reconstruction of all the transactions, which means that who has recorded it, who has approved it, who has passed it, who has shared it. All the transactions that you do will be recorded in something known as an audit log. Audit log. Audit trail objectives, detecting unauthorized access, reconstructing events. I can trace back to an event, I can trace back an event to its origin. Reconstructing of events. Personal accountability. Okay, at every step through the log, I will know which person has passed what entry, which person has given what access rights to the other person. So, I will know everything with their names, So, I can hold them responsible in case of anything. So, personal accountability, Audit logs, implementing an audit trail. 4th is, so audit trail objectives, 4 objectives, okay. Detecting unauthorized access, reconstructing events, personal accountability and audit logs. Implement an audit trail. Audit logs, implement an audit trail. Next I have is information systems controls. Information systems controls. Okay. So, clear with auditing. We are moving on to our next topic, information systems controls. Now, see, in the computerized environment, you understand how important is it to put controls. Yes. Now, in a computerized environment, in a normal uncomputerized environment, it is easy to put controls because see, I just have to have some physical controls such as maybe fire alarm or some fire detectors, and then I have some locks on doors. Yeah. I can have a security guard, I can have a CCTV camera. So, when it comes to physical controls, it is slightly easy. But when it comes in a computerized environment, what happens? Computerized environment, what happens? So, 3 lakhs, 3 absences and 2 others. 3 lakhs, 3 absences, 2 others. So, first is lack of management understanding of the information systems risks and controls. The management does not understand what are the risks or what are the controls that are going to be that needs to be implemented. Lack of management understanding. Okay, so 3 points on lack. One is lack of management understanding. Lack of awareness and knowledge. Lack of awareness and knowledge of the risks and controls. Lack of control features in a highly tech-driven environment. When the environment is super technologically oriented, you don't know what are the controls that are best suited in that case. So, lack of control features in a highly tech-driven environment. Absence of IS control framework. Absence of, so 3 on absences. Absence of IS control framework, absence of general control and application. So, first of all, the framework itself is missing. Second, general controls are missing, application. If you remember, there are 2 types of controls. One is a general control, one is an application control. Now, both these controls or either one of this control is missing. First, the framework itself is missing. Yeah. Second, the controls are missing. Absence or inadequacy of security measures. Security measures very less. Absence or inadequacy. And 2 others, inappropriate technology and complexity in implementation of controls. So, first, the technology that implementation is inappropriate. Yeah, I am using the wrong technology for the wrong task. Next is, it is very complex to implement controls, because see, I have, if you see the network diagram, then I have routers, switches, hubs. Yeah, I have the firewall, I have connections, I have bandwidth. So, in which place can I put in my controls? For which place should I have files, folders, where should I actually put in my controls? So, complexity in implementation of controls. IS controls, controls lacking in computerized environment. What are the controls that are lacking in a computerized environment versus a physical environment? 3 points on absences, 3 points on lacks, 3 points on absences and 2 points on others. Clear, guys? Yes? Very good. Now, the IS controls, information systems controls, are divided into 3 buckets. One is on the basis of objectives of the controls. Okay, what are the objectives, or what does the control want to achieve based on the objectives of the control? In objective, we have 3, PDC, preventive control, detective control and corrective control. Preventive control, detective control and corrective control. Clear? Next, I have on the basis of IS resources. On the basis of IS resource, I can have environmental control, physical access control and logical access control. We will study each one of these IS resources. Based on that, I have environmental, physical and logical. Resources could mean my servers, computers, infrastructure. Yeah, so all that needs to be protected from environmental risks, from physical access risks and from logical access risks. Based on my IS functions, I have management controls and application controls. Management controls and application controls. Clear? So, based on objective of controls, based on nature of the resources and based on the management or application, based on the IS functions. Clear? Wonderful. So, based on the objective, if you can remember, we have PDC, preventive, detective and corrective control. When I talk about preventive control, it means that I want to prevent errors or omissions or any malicious acts from occurring. I want to prevent it. For example, what can I do to prevent things from happening? I can have a password. Yeah, I can have locks on the door. I can have an access register, where only authorized people are allowed to enter the office. So, all these are preventive controls, that are put in place so that mishaps do not even happen. Antivirus, firewall, segregation of duties, all these are preventive controls. Segregation of duties, so that I ensure that errors are prevented. Detective controls. So, even after putting preventive controls, there are ways by which errors or omissions will happen. Okay. So, for example, CCTV camera, it cannot prevent a thing from happening, but while it is happening, it can detect it. Okay, something wrong has happened here, and this is the person in charge. A CCTV camera will be able to detect that. So, next is detective control. Detect error, omissions or malicious acts. Understand the unlawful activities. Understand what is unlawful, understand what shouldn't be done. Only then you will be able to put in the right detective controls. It is investigative in nature. It goes to investigate. Okay. Example, counting the cash. You're not preventing any error, but you're just checking if, detecting if any, if the cash balance is different, you're just checking that. Monitoring actual against budgeted, CCTV. Monitoring the actual reports, actual expenditure against the budgeted expenditure. If there's a lot of variance, then definitely something wrong would have happened. What wrong has happened, you have to detect now. Clear? Last is corrective controls. After errors have been detected, what do you do to correct it? What do you do to correct it? Example, program debugging means removing the error. Removing the error. Correct errors, omissions or malicious act after they have been detected. After they have been detected. It is reactive in nature. So first the detective controls were investigative in nature. This one is reactive in nature. After you find out that something has happened, what do you react to it? How do you correct it? Example, complete change to the IT access list. I change my IT access list completely once the role of the employee changes. Okay, once the role of the employee changes, I completely change the IT access list. So for example, if someone is in the if someone was in the finance department, he would have access to payment of salaries and he would have access to recording of expenditure. Clear? But from finance department, he's moved to the say marketing department. He's moved to the marketing department. So I do not need, I will now remove his salaries access, remove his expenditure access. He can only give a reimbursement claim for any expenses that can be made. Okay, complete change to IT access list once the role of the employee changes is a corrective control. Police report, I go and report to the police, that is a corrective control. Debugging software, correcting the errors in a software. Clear? Now we have a few environmental controls left. Environmental controls, very, very simple, basic, easy. Okay, one is fire. How do I protect my office against fire? How do I protect my office against fire? First I put smoke detectors, very good. Next, norms to reduce electric firing. What is the meaning of electric firing? When too many systems, too many internet connections, too many modems are all kept together, connected with electricity, then there is a chance of a spark, fire due to electric spark. So, norms to reduce electric firing. Now, how can I reduce that? By locating my computer room in such a place that it is safe from the fire. For example, if I can't locate it on the ground floor or in the basement, I have to locate it somewhere on the higher floor. And in the computer room, I need to have fireproof ceiling, fireproof walls. I need to have, less of material or no material that can conduct fire, that can attract fire. Fire extinguishers at strategic locations. I need to have fire extinguishers at strategic locations. Fire alarms, and those alarms need to be loud and they need to be placed correctly where the authorized person is there in order to act. It can't be placed next to, say the security guard. He may not know what to do. It needs to be placed against a trained, it needs to be placed with a trained person. Regular inspection and raising awareness. So, by way of fire drills, I need to have regular inspection of my IT systems, of my infrastructure, and I need to have awareness camps going on. Documented and tested emergency evacuation plans. Okay, documented and tested emergency evacuation plans. You know that fire exit which is there. Yep, fire exit. So, all these are documented and tested emergency evacuation plans. Clear? So, these are a few basic logical things that you do in order to avoid fire in your computer rooms. Next is electrical exposures. So, first is electric surge protectors. Due to power spikes in UPS, due to power spikes in UPS, what will happen is the system will get damaged. So, in that case, you need to put electric surge protectors in the UPS so that power spikes do not happen, or power spikes, if they happen, do not affect the computer systems. Clear, guys? Yes. Next is uninterruptible power system, which means a generator, UPS. This UPS point is covered here. Now this UPS keeps my system running for a few minutes even after the power is off, right? It keeps my system running for a few minutes even after the power is off. In that case, that system needs to be properly maintained. Emergency power off switch. At strategic locations, I need to have power off switches. Power off switches, so that immediately one authorized personnel, it shouldn't be there at every place, you know, where, you know, any Amar Akbar Anthony can come and switch off the entire electricity of the company. It needs not be like that. Some authorized personnel next to him or her, the switch must be there, and he needs to know when he needs to power it off. Voltage regulator and circuit breakers. Sometimes due to power peak or power spike, power low power, high power, due to changes in power, sometimes there could be circuit breaker, fire. So in that case, there needs to be circuit breakers and voltage regulators. Clear with the environmental controls that we have here, electrical exposures. So here we need to put in all this so that our information systems are safe. Next, water damage. What will you do to save your systems from water? Water detectors, strategically locating the computer room, and few other ways to protect water damage. Next is pollution damage. Power leads from to substation. Prohibition against eating, drinking, smoking in the facility. Okay. So, you should not allow any eating, drinking, because dust, pollution means what? Dust. Right? Dust pollution, noise pollution, air pollution, right. Now, you need to do all this to protect the system. Okay. Next, under physical access control, we have physical security of tangible and intangible resources. Physical security of tangible and intangible resources. Locks on door, very easy topic. Cipher lock is the number lock. You enter 4-digit pin and enter the room. Cipher lock or a number lock. Bolting lock is like a metal key. It's a huge metal key. You have to do that. So, please note we are doing physical access controls. We finished environmental access controls. Under that we did fire, electric, water and pollution. Now we are moving on to physical access control. Under physical, the first point that you will do is put a lock on door. What are the different kinds of locks? Cipher lock, bolting lock and electronic door lock. Physical identification medium. So, people are coming in, you need to physically restrict them, right? Physically restrict them. So, what will you check? You will first check if they have the pin or not. If they have the pin, they can enter the pin and come in. If they have the plastic card, identity card. If they have identity badges. Plastic card is like visitor card or an employee card, right? Then we have logging. Manual logging and electronic logging. Clear? Which means near the security, there will be a register. In that register, you have to enter your name, your time in, your phone number, the purpose of your visit, who do you want to visit, your signature, all that is known as manual logging. Electronic logging could be the same on an electronic screen. For example, you stand in front of a system, that electronic logger, and you put your face and a printout comes, yeah. When we go to passport office or such things, then this is the way of recording who has entered the premises. Electronic logging. Apart from locks, apart from identification mediums and apart from these logging facilities, we have other means. Other means could be CCTV camera, security guards, some watchdogs. We could have controlled visitor access, bonded personnel, make the staff sign a bond, you know, to minimize the financial damage due to theft of an asset. Make them sign a bond that in case they do that, their jobs will be lost. Yep. Dead man doors. Dead man doors are like two doors. Only when one door closes, the other door opens, and between door 1 and door 2, only one man can stand. So, usually computer rooms are given that access. Or bank lockers. Bank lockers have two doors. One is opened and the other, then the other, this closes, and only then the other door will open and you can go in. Dead man doors. Non-exposure of sensitive facilities. Non-exposure of sensitive facilities. Do not have windows, yeah, or some window sill or some ladder or some way where you can go and access that room. Do not have all of these exposures in the sensitive rooms. Computer terminal locks. Computer terminal locks, where the computer or the computer assets are stored, you can have a lock. You can have a lock. Control single entry point. So, in case there is a back door, front door and back door, then through the back door, it is possible that people can come in. So, single entry point, single entry point. Alarm system, perimeter fencing. Alarm system and perimeter fencing. Perimeter fencing is nothing but have fences, big, walls, so that people cannot enter. An alarm system is have an alarm ringing. Control of out of hours of employee. Yeah, in case people are accessing the office beyond office hours, then keep an extra check. Secured card, any reports to be distributed, all of that needs to be kept under check. Under logical access controls, we have controls relating to logical access of information resources, implemented to ensure that access to the system, data and program is restricted, to protect information against unauthorized use, disclosure or modification. While designing logical controls, we need to keep a lot of things in mind, okay. It's what are the firewalls, what is the security administration, the training, the tools and all of that. Now, controls for user access management. User access management. We finished physical, we finished preventive, detective, corrective, okay, based on objectives. Then based on the information system resources, we had environmental controls, yeah, and physical access controls and logical access controls. Now, under logical access controls, physical means physically someone is coming, stealing the data and going. Logical access means someone is entering the computer system and in that they are modifying or editing the data. So, guys, we are doing logical access control, and under logical access control, the first control that we are going to see is user access management control. User access management control. User registration and deregistration, which means that when an employee comes, joins in the firm, then I need to give him a user ID and password, okay. And when he exits the firm, I need to make sure that I take off that registration and password, okay. So, he should not be allowed to access the servers or the company's files after he leaves the firm. So, user registration and deregistration. Privilege management. Privilege management. What are the documents that he can see? What are the files that he can access? What are the softwares that he can use? Yeah, privilege management. I need to manage what are his privileges. Can he go into the configuration of the system and change all of that? Can he give rights to other employees? No. Okay, I need to manage what are his privileges. User password management. User password management. Now, when I say here password management, I need to have strong rules such as password needs to be changed once in every 3 months, password needs to be a strong password, used for password management. Review of user access rights. So, continuously you have to review that, okay, the user rights, in case someone is moving from one department to another, you need to make sure that the access rights have changed. Access rights have changed. So, very simple, user access management, 4 easy points. 4 easy points. Come on, let us revise. User registration and deregistration, user registration and deregistration, privilege management, then we have user password management, and finally review of his access rights, Clear? Wonderful. Controls for user responsibility. Now, that was user access. This is his responsibility. What is his responsibility? His responsibility is to keep his password very strong, and his responsibility is to shut his computer when he is moving away from his terminal. Password use, unattended user equipment. When he is away from the computer, he needs to lock that computer. Clear? Network access control, PS fences, network access control. Under that, the code word for us to remember is PS fences. We all know what is a network, yeah, connecting to the internet or connecting through remote login or connecting to any cloud-based app. All these are the network access controls. Now, this network access controls is an important question. You can remember the points using the code word PS fences. PS fences. Let us quickly see what is PS fences. Policy on use of network service. S for segregation of network. Segregation of networks. F for firewall. F for firewall. E for enforced path. Enforced path. Enforced path. N for network access controls. C is for callback devices. E is for encryption. S is for security measures. Security measures. Right? So, policy on use of network services needs to be strong. You need to place responsibilities, you need to place the hierarchy in case of a security breach, what is going to happen. Policy on use of network services. Segregation of networks. Okay, segregation of networks means that the branch and head office needs to be, for example, the data that is going between them needs to be stored on a different network, not on the same internet that is used for all other transactions. Yeah, the information that is flowing from branch to head office needs to be on a separate network. Segregation of a network. Third is firewall. Firewall means it's like a traffic police. It helps it. So, from my organization's computer, if I give a request that, okay, I want to visit Facebook. Now, this will go through the firewall. Only if the firewall allows, I will be able to access the Facebook website. Otherwise, it will bounce back saying that you're denied access to this website. Clear? So, firewall is from both the sides, from the organization if it wants to access anything on the internet, or if any disruptive file is coming from the internet to the organization's network, in that case also firewall will protect. So, it is a firewall on both the sides. Clear? It's like a traffic police. It maintains the traffic between networks. Enforced path. Enforced path. It is how the information should travel, which network it should travel, what path it should take. Network connection and routing control. Network connection and routing control. Now, we've already discussed data travels from source to destination in data packets. Now, how that data packets need to be traveled needs to be properly documented. Callback devices. Callback devices. Callback devices. So, earlier what used to happen is when we wanted to connect to an external network like the internet, we had to set up a dial-up connection. Now, this dial-up connection would go and ask the terminal, okay, that this is a request received from this IP address. Should I allow it? Yes, in that case, a simultaneous callback would be would be sent to this computer, and only when this is accepted. So, it's like a call which is made back, and only upon accepting that call, a connection is established. A connection is established. Encryption of network. I need to use private key, public key. I need to use ciphertext to encrypt the information that is going through the network. Security of network services. Security of network services. Need to ensure that I place in proper security measures when it comes to network services. Okay. So, policy on use of networks, segregation of networks, firewalls, enforced path, network connection and routing control, callback devices, encryption and security. PS fences. You can remember this as police station fences. Police station, PS. Fences in police station, PS fences. Network access control. Network access control. Yes, everyone's clear with the points here? Wonderful. Next is operating system access control. So, first what we did was user access management. Then is his rights, user responsibilities. After that we studied network access control. Now we are seeing operating system access controls. The Windows OS that we have. Windows OS, yeah. How can you control the access to the operating system? That is the first level of entry into any system. Only after you can crack the operating system, you can touch any file which is there on the system. Clear? So, we need to see how we can stop it at the first point of defense. Now, we have 2 points on identification, 3 points on access, 3 points on time and 3 other points. Okay? 2 points on identification. automated terminal identification and user authentication and identification. So first is terminal identification. If you have tried accessing your bank account or your email ID from another country, say Singapore or Sri Lanka, then it does not open at once. It says that the location is not identified and it asks you for additional security access, right? Additional security controls. So automated terminal identification, even my network needs to be so strong, or my operating system needs to have that control, that if someone is trying to access my organization's data from some other XYZ location, yeah, then it could probably be a hacker who's trying to access my organization's data. So I need to put in automated terminal identification, that this information was, attempted to be accessed from some computer in Italy, some computer in Paris. So I will get, I will restrict that. Automated terminal identification. You have to check the location from where this OS is trying to be accessed. Next is user identification and authentication. Need to check if the user is a correct user by, they will have the user ID and password. Okay. Next we have 3 points on access. Access token, access control list and discretionary access control. Access token, access control list and discretionary access control. Yes. So access token is something like, I will ask, can I access this system? Now when I ask, it will compare it with my access control list. It will compare my requirement, what I'm asking for. For example, I ask to open the in my ERP tab, I ask to open the GST filing tab. Once I click onto the GST filing tab, it checks that okay, this user, is she allowed to access the GST tab. So it will check for my control list. Now, if this requirement and this list is matching, then it will give me access. Otherwise, it will say access denied. Otherwise, access is denied. Clear? So, access token and access control list. Access token is like I'm going to a restaurant and asking for juice, asking for a glass of fresh fruit juice. Now, access control list is like the menu. In the menu, they will check if the juice is available, then yes, they can give it to me. If it's not available, if it's not a juice place and juice is not available, then they cannot give it to me. Clear? Access token, access control list. Then I have discretionary access control, which means I can decide who I want to give access to and what additional access I want to give. Discretionary, based upon decision, the management can decide who to give access to. 3 points on time. Duress alarm, terminal timeout and limitation of connection time. So then it's duress alarm. So in case of any situation where someone is trying to get extra information from me, or I have understood that someone is accessed my computer and they're going to take in confidential information, in that case I need to have an option to press the SOS button, which means press an alarm and highlight the system administrator. Terminal timeout. In case my laptop is or my PC is inactive for certain number of minutes, it needs to time out by itself, because when it's on, then all the files are accessible. Limitation of connection time. I cannot connect to my computer after 11 p.m. I cannot connect to my organization login after 11 p.m. So limitation of the connection time. And 3 points others, which are password management. Need to have a strong password management policy in the company. Use of system utilities. Use of system utilities. What is the meaning of system utilities? Like my printers, all the other resources of the computer. I need to ensure that I have defined proper access. RBAC, who can access what? Terminal login procedures. Terminal login procedures need to define from where, which location can the terminal log in, and in case it's logging in, some additional security measures need to be put in place. Additional security measures. Clear? Finally, we have application and monitoring system access control. Application and monitoring system access control. The code for this is EISQ. Okay, E for event logging. Application and monitoring system access control. So who has access to the system. So have a log of events. Okay, have a log of events who has gone into that. Next is information access restriction. information access restriction. Information access restriction. In that case, restrict the access only to the authorized users. Restrict access only to the authorized users. And S-cube, sensitive system isolation. Whenever there is some sensitive data or system which has sensitive data of the company, please store it not with the normal systems in the normal office bay, but store it separately in a separate server room or a separate computer room. Sensitive system isolation, or you have the servers where main data is there, store that separately. Don't store it with the other resources of the IS system. System use needs to be monitored. And clock synchronization. Clock synchronization means I need to check the timings of who can access the system when. And the system can be accessed from multiple locations around the world if I have offices around the world. So I need to synchronize a time so that the changes can be recorded correctly in my log file, event log file. Clear? So application and monitoring system control, E for event logging, I for information access restriction, S stands for sensitive system isolation, synchronization, clock synchronization, C, clock synchronization and system use, monitoring system use. Okay. And then when mobile nowadays work from home, all the things can be done from a remote location. I don't need to necessarily be there at office. In that case, computer facilities are not restricted to the data center. Okay, remote also it's on the go. In that case, I need to have encrypted information, access identification such as two-factor authentication, fingerprints, smart cards. All these are extra measures or extra controls when the data is mobile. When your information resource, for example, the employees can work from their homes also through their laptops. In that case, I need to have all these things. Otherwise, I will have a risk of data theft. Okay. So in the previous unit, we had seen questions from chapter 3 on IS components, hardwares, difference between RAM and ROM, VI, PI, CC, SS, output types, software, activities of operating system, where we had, hardware and management. 2 points on hardware and 5-6 points on management. Then we had advantages of DBMS, types of DBMS, advantages, disadvantages of DBMS, types of DBMS, big data benefits and data warehouse. And in this chapter, we have seen physical controls, logical controls, physical controls, logical controls, before that preventive, detective and corrective controls, along with a few data mining techniques. So we will see in the next learning unit. Thank you very much.